The team was required to design a steel portal frame structure with a predetermined rafter load of 8 kilonewtons per metre, a building length of 45 metres, a frame span of 25 metres and an eave height of 8 metres. All of the parameters for this design were determined from the LISAT guidelines, which can be found on their website. The following universal beams were used for the columns and rafters. A 5,000mm spacing was used for the columns to comply with the maximum 6,000mm restriction. The LISAT Block Classic 7000 cladding guidelines was used to design the purlins. An end span of 1800mm and internal span of 2200mm was used. The Z15024Z section was chosen with a nominal spacing of 5,100mm to meet the 5,000mm frame spacing and to withstand the 1 kN per metre inward and outward load. The LISAT custom mould cladding guidelines were used to design the girts. An end span of 1800mm and internal span of 2400mm was used. The C15024C section was chosen in order to withstand a 1 kN per metre inward and outward load. The portal frame was then analysed in space gas, with internal and external wind loads being applied, as well as the live and dead loads of the structure. With the assumption that the build was taking place in Wollongong, the wind conditions were taken from the A2 region in accordance to the wind loads from the Building Code of Australia. The maximum internal and external wind loads on the structure are 3.77 kilonewtons per metre and 2.64 kilonewtons per metre respectively. The live and dead loads are 1.23 kilonewtons and 0.49 kilonewtons respectively, in a downwards direction as determined through space gas. The load paths for this structure are such that the vertical loads through the roof travel through the purlins, rafters, then into the columns and foundations. The horizontal loads are transferred through the walls, into the girts, and then finally into the columns and foundations.